Hello students. In today's lecture, we are going to discuss that how metallic oxides react with acids and how non-metallic oxides react with base. We will also discuss that what are the reasons because of which acids and bases show their acidic and basic properties. So let us start with today's lecture. Reaction of metallic oxide with acids. Now what does it mean by metallic oxide? Any metal, when it reacts with oxygen, it forms metallic oxide. For example, magnesium oxide, sodium oxide, zinc oxide, they are all examples of metallic oxides. Let us see the reaction. Metal oxide, when reacts with acid, it gives salt and water. Copper oxide, when it is treated with hydrochloric acid, it will give copper chloride and water molecules will be released. Now the reaction you will observe here, but with that there will be color change will also be seen. Copper oxide, which is black in color, after the reaction it changes to blue color, which proves that a new compound has formed. Another example is with aluminium oxide and hydrochloric acid. The corresponding salts, aluminium chloride and water will be formed. If you take zinc oxide and with that sulfuric acid, we will get zinc sulfate and water molecule. Wherever the reaction needs to be balanced, we need to put the numbers, like here we will write 6 before HCl and 2 before aluminium chloride, 3 before H2O to make this reaction balanced. Reaction of non-metallic oxides with base. Non-metallic oxides such as carbon dioxide, sulfur dioxide, sulfur trioxide. How does these metallic oxides react with base? Carbon dioxide, when reacts with calcium hydroxide, it forms calcium carbonate and with that water molecule. Now this reaction we have already discussed when we were discussing the conformation test of carbon dioxide. Now let us discuss one more time the reaction where metal oxide and acid react to form salt and water. We have discussed such type of reaction in the previous session where we have discussed neutralization reaction. In the neutralization reaction, base reacts with acid to form salt and water. And here, metallic oxide is reacting with acid to form salt and water. So in this condition, we can also say that metallic oxides are basic in nature. This type of questions can be asked in your exam to explain that metallic oxides are basic in nature. We can also confirm it with litmus test. When you dissolve metallic oxides in water, you will get metallic hydroxide. And in metallic hydroxide, when you will put red litmus paper, it will turn blue, which proves that metallic oxides are basic in nature. What do all acids and bases have in common? We have discussed that acids and bases are opposite to each other. They show some different type of reactions. But here we will find out that what things they have in common. For that we have to understand one activity which is given in your textbook. This is a setup in which we have taken beaker, iron nails, cork, wires, battery, bulb and switch. With the help of all these things, we will prepare a circuit and in which all the components are connected to each other. Now in this case, the two iron nails are attached to the rubber cork which is not a good conductor of electricity, which means this circuit is incomplete. So what will happen if we will add few amounts of hydrochloric solution in it? Let us see that when we add hydrochloric solution in it, the bulb will start to glow. What makes it possible? It is because when the hydrochloric acid is added in this setup, hydrochloric acid will break down into H plus and Cl minus ions. And in this case, there are charged particles which can easily conduct electricity in a circuit. We know that charged particles are required to conduct electricity. What will happen if in place of HCl we will take any other substance like glucose? Glucose has formula C6H12O6 and we can get glucose solution by dissolving glucose powder in water. So we will place some amount of glucose solution in this beaker in the second setup. Here you will observe that when we put glucose in this beaker, the bulb will not glow. Now what is the reason behind it? It is because that glucose is a substance which is made up of covalent bonds. And whenever you add glucose in water, it does not get ionized or it does not dissociate H plus ions. So because of the lack in ions in this kind of solution, the electricity will not conduct it because there are no any charged particles to conduct electricity, which means that glucose is not a good conductor of electricity. In the third setup, we will put sodium hydroxide solution. What will happen when we will put sodium hydroxide solution in it? Again, because the sodium hydroxide solution is aqueous solution, here also we will get ions. Na plus and OH minus ions are produced. Now, because there are charged particles present, the electricity will be conducted and the bulb will start to glow. So, in both the cases, that is HCl and NaOH, the current will be flowing and the electricity will be passing, which means that both HCl and NaOH are capable of conducting electricity, which means they are electrolytes. Electrolyte means any liquid which is capable of conducting electricity is known as electrolyte. So these are the properties which are common in acids and bases. Next, we are going to discuss about hydronium ion. What does it mean by hydronium ion? We have to discuss one activity to understand about hydronium ion. Whenever H plus ion combines with water, it forms hydronium ion. Now see, in this activity, you will see that there is a test tube in which sodium chloride salt has been taken. In this sodium chloride salt, some amounts of concentrated sulfuric acid will be added. We have taken concentrated sulfuric acid so that the water content will be minimum in it. When these two substances will react with each other, they will form sodium sulfate salt and with that hydrogen chloride, that is hydrochloric acid gas. In this reaction, we will put a cork on the top of the test tube so that the gas which is passed, it should not go out of the test tube but it should come out through the delivery tube. Now in this reaction, when we will put a dry litmus paper, dry blue litmus paper near the test tube mouth, there will be no color change seen in the litmus paper. Why it doesn't change even though the gas which is coming out is an acid? This is because that when acid gas, that is HCl, is coming out of it, it is not coming in contact with water. So let's see what happens when we put moist litmus paper near to the mouth of the test tube. Here now we will take the moist blue litmus paper near to the delivery tube, and then you will observe that the blue litmus paper has turned red, which means that water plays a very important role in an acid to show its acidic property. In this process, when HCl is dissolved in water, the H plus ion which is released by HCl gets combined with water molecule to form hydronium ion, HCO positive, and with that chloride ion will also release. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen ions must always be written or shown as H plus, and with that aqueous should also be mentioned, and hydronium ion like this we can write H3O positive. So it is the formation of hydronium ions. H plus plus H2O will form hydronium ion. We have seen that acids give hydronium ion or H plus aqueous ion with this activity. Now let us see what happens when base dissolve in water. When a base like sodium hydroxide is dissolved in water, sodium hydroxide also breaks down into Na plus and OH minus. Like in acid, hydronium ion is necessary to show the property of acid. Similarly, in the base, hydroxide ion is necessary to show the property of base. I hope it is clear. Hydronium ion is responsible to show the property of acid, and hydroxide ion is necessary to show the property of base. Bases which get dissolved or soluble in water are called as alkalis. Some more examples of alkalis are potassium hydroxide. It breaks down to form potassium and hydroxide ions. Magnesium hydroxide breaks down to form magnesium ion and hydroxide ions. So students, now we are going to discuss about dilution of acid. First of all, what does it mean by dilution of acid? Which means adding some amount of water to decrease the concentration of ions. Let us see the diagram. Now here you can see the dilution of acid, which means that when the water is being added in the acid to make it little bit less concentrated. Now this process you can see over here in this beaker containing acid. Always remember that whenever we have to dilute an acid, we will never add water in acid, because this process is highly exothermic. In an highly exothermic process means a large amount of heat is produced, and if any person will try to add water in acid, the person will get severe burns. To avoid such kind of situation, we should always add acid in water. In this diagram, you can see that the person has used dropper to put acid in water drop by drop. In this way, the heat which is produced will not be in a large amount. And with the putting water, the continuous stirring with a glass rod is also required. So when we stir the solution with the help of glass rod, the heat which is generated is evenly distributed throughout the solution. And that is why this procedure is much more safer than the previous one. In this situation, when the water is poured, the water which has come in contact with acid will change into water vapor with a large amount of heat, and that water vapor will start coming out of the container and will cause severe burns to the person. So that is why it is important to add acid in water, but not water in acid. So this is how the dilution of acid takes place. I hope this concept is clear to everyone. Now we will continue in the next lecture. Thank you.